Today we will discuss process scheduling in operating systems. So to understand process scheduling, we have to see process scheduler. So a process scheduler is a program that selects an available process from a set of several available process for program execution in the CPU. So generally during a particular point of time, we can consider there are several processes available in the system. So the process scheduler selects one process from that available list and put it in the CPU for execution. Now why process scheduling is required? Process scheduling is required because of the first thing, that is called multiprogramming, so that the CPU utilization is to its maximum, that is CPU is always busy. So that is why we need process scheduling, because the CPU will be switching from one process to another process. While one process is busy in input output, the CPU will be executing other process. Also, in case of time sharing, the CPU switches among the process so frequently that the user can interact with each other while it's running. So that is why we need process scheduling. So the scheduler program is responsible for scheduling the processes, that is which process will execute first, which will execute second, and so on. Now let us look at process scheduling queues. As there are several processes, so all the processes are put in queue so that they can be executed in some order. So the first queue is called job queue, where all set of processes in the system are put in the job queue. Second, Radicu, the set of all processes residing in main memory and that are ready and waiting to be executed. Third, device queue, the set of processes waiting for input output operation or input output devices, and the processes migrate between one queue to another queue. For example, it may move from job queue to Radicu, then to device queue, or from Radicu to device queue to back to Radicu, and so on. So let us look at the example of Radicu and various input output device queues. So in the example, if you see the first one, we see this is a Radicu and there are two processes in the queue, process 7 and then process 2. So they are represented using their PCB, process control block. So process control block for process 7 and process control block for process 2. And if you see the queue, the first process in the queue is represented by this particular pointer head, and the last process is represented by the pointer tail. So in between there can be several processes, so each process will contain again a pointer to the next process in the list. Similarly, you can see there is a device queue for magnetic tape, and the head and tail, if you see, initially these are null. There is also disk unit which has three processes, process 3, process 14 and process 6, and the head is pointing to the first process and the tail is pointing to the last process. In between there can be several processes as shown here, that process 3, after that process 14, then after that process 6, and they are all represented using process control block. So PCB contains all the information associated with a process. Representation of process scheduling. So let us look at this particular example and understand how process scheduling takes place. So initially there is a job queue, all the processes are in their job queue, and then they are moved to the ready queue. Now you know already that queue works in first out manner. The process which comes first will be executed first, the process which comes last will be executed last. So all these processes are now in the ready queue. Now the first process will be moved to the CPU for execution. Now while the process is in execution in the CPU, there can be several possibilities. One of the possibility is that there is a input output instruction in the program or in the process. So the process will need a input output, so it cannot run in the CPU. So that is why it will be halted and it will go for a input output request. Now because input output request, there can be several devices which can need input output, so it has to go to a input output device queue. So after the input output has been granted to that particular process, it will execute in the input output, for example taking an input from the user, and then it goes back to the Radicu. Or there is a possibility that the CPU in which the process is running, there is a time slice, that is the process will run for a certain duration of time. After that time it will be taken out of the CPU and the new process will get a chance, or the second process will get a chance. Generally every CPU maintains a time slice. Why this time slice? So that every process gets the equal opportunity. So for example, first 2 millisecond can be given to process 1, second 2 millisecond can be given to process 2, third 2 milliseconds can be given to process 3, and so on. So there can be several processes each given 2 milliseconds, so they may go to the Radicu to the CPU, then they can be taken out from the CPU because their time expired, and then they goes back to the Radicu again. So the process may run several time through the Radicu, and finally it may complete its execution, so it will come out. Also there is a possibility that the process may create a new process. So when a process creates a new process, in that case it is again taken out of the CPU. So when the child process, because process has created a new process which is also called the child process, so when the child process completes its execution, then the parent process can continue its operation. So in that case, because a new process is created, it will go to the Radicu and will wait for its turn. Also there is a possibility of interrupt. So when the process is executing in the CPU, there may be an interrupt from the operating system. So in that case, the last option, wait for interrupt. So the process will be taken from the CPU and it will wait for the interrupt to finish. When the interrupt routine or interrupt program has finished its execution, then it will go back to the Radicu and again wait for its chance. So if you see, there are 4 possibilities in which a running process in the CPU will be halted. One is the input output request, second the time slice, the duration of time for which it will run in the CPU. Once it has expired, it will taken out. The third, the process has created a new child process, so the child process must run. And fourth, there is an interrupt from the operating system, so the process has to wait for the interrupt to finish. So these are the 4 possibilities when a process is running in the CPU. So that is why we need a scheduling, so that in each of these cases it goes to the Radicu and then it moves back to the CPU. Next we see scheduler. So generally there are 2 types of scheduler. One is called long-term scheduler and another one is called the short-term scheduler. Long-term scheduler is also called job scheduler. So the long-term scheduler selects process which should be brought into the Radicu. So from the job queue it is brought to the Radicu. And the short-term scheduler, which is also called the CPU scheduler, selects which process should be executed next and allocates the CPU. So the long-term scheduler will bring the processes from the job queue to the Radicu, and the short-term scheduler will move it from the Radicu to the CPU and then back to the Radicu, then CPU, and the process will continue until the system or the scheduling program finishes the execution of the particular process. There is also one more scheduler or scheduling technique which is also termed as medium term scheduling. In this, if you see, the process is in the ready queue, it goes to the CPU, and then after some time it is swapped out. The process may have completed partially, so it will be swapped out and then it will be swapped in back to the queue. The main idea of medium term scheduler is that it is sometimes advantageous to remove processes from memory and reduce the degree of multiprogramming. Also, the process can be reintroduced into the memory at a later stage and can be made to continue from where it let off. This scheme is called swapping. The process of swapping in and out several times by the medium term scheduler is necessary to improve the process mix, so that there are several processes and everyone gets its chance. Also, to change the memory requirement, as there may be a possibility that the memory needs to be made free, so the process needs to be taken out of the CPU. So that is why swapping is done in and out several times. Continuing with schedulers, short term scheduler is invoked very frequently in millisecond and must be very fast. As you know, the process goes to the CPU, then to the ready queue, and this switching takes place very frequently. That is why it has to be very fast. In case of long term scheduler, new processes will come in from the job queue to the ready queue, so the process may be little slow. The long term scheduler controls the degree of multiprogramming. Multiprogramming concept we have already discussed. And there are two concepts of multiprogramming, that the processes can be input output bound processes or it can be CPU bound process. If it is input output bound, that means it is spending more time in input output operation, then it may need short CPU burst, that is it will take less CPU time. Some processes which are CPU bound spend more time in CPU, whereas they will taking less time in the input output, so they will need long CPU burst or long CPU time. So that was about scheduler. Coming to context switch, when CPU switches to one process to another, the system must save the state of the old process and load the save state of the new process. We have already seen this in the last video lecture. When context switching, time is overhead. The system does no useful work while switching. So when the CPU is switching from one process to another, between the switching it does no work. So more the switching, more the time the CPU will be idle, so it will not be doing any task. Context switch is also dependent on the hardware support, so that it can be managed properly, so that the CPU time is utilized to its maximum, so that the switching between the processes is such that the time is wasted minimum between the switches. So that is about context switch. Thank you.